Hello there. In this video we're going to be looking at equations of tangents to curves. So as we've already seen in the video 11, where I explained that we define the gradient of a curve as the gradient of the tangent line at that point of the curve. So just to recap, if I look at this point here, the gradient of the slope at this point, the curve at this point, we would define as the gradient of the line which is tangent to that point. And as I mentioned in previous videos, we don't get a singular answer for this like we would in a straight line. The gradient varies as we go along, and so we represent that and we see that when we actually derive it. So when we differentiate, in this case y equals x squared, that will be 2x of course, we will get a gradient which is also represented as a variable, or has a variable in it, and that represents what you can see here is that the gradient is constantly changing. So here I have an example. Here I have a smaller version of that. So we have again y equals x squared, and I have the point 3, 4, and what I want to do is find out what is the gradient of the tangent line at this point 3, 4, and I've kind of just drawn this in. So first of all, let me write my equation. So we're dealing with y equals x squared. And if we want to talk about gradients of curves like this, then we should of course differentiate it. So we're going to take dy by dx, which would equal 2x. And this is the general form of the gradient. So now I can plug in values of x here to find out the gradient at a particular point. So there's a couple of ways that you can notate this. The sort of formal kind of way would be if you take dy by dx and we draw a line here and we say x equals, and in this case we see the x component is 3, and so that would equal, and we're subbing this in, so that would be 2 times 3, which is 6. So we see here that the gradient of the tangent line at this point is 6. This notation isn't commonly seen in higher, but I've put it there anyway in case your particular teacher uses it. I think a more common way you would probably do it in higher, if I just put it to here, is to say dy by dx and just sub the value in. So we'll have 2 times 3, which is 6, but just note that this is not dy by dx unless you specify that it's at x equals 3. So you just kind of have to remember to put this on the side when you're going to sub this in, but either way is fine. So here I have an example again. We have find the equation of the tangent to the curve y equals x cubed minus x plus 2 at the point P 2, 8. So you notice that this is slightly different from the previous question. The previous question was only concerned about finding the gradient of the tangent, whereas in this example we actually have to find the actual equation of the line, remembering that a tangent is simply a straight line. So I really hope you would know by now, if we want to have the equation of any straight line, we need the gradient and the y-intercept. Now, we don't clearly have the y-intercept here, but we know that we can find the gradient, and we know that if we have the gradient in a point, then we can use the y minus b formula to find it. So that's the general outline, but let me work through this. So let's find the gradient. So we'll have first dy by dx. So we're going to differentiate this with respect to x, and we will get 3x squared minus 1. And we're interested in evaluating this at the particular point P 2, 8. So we see that the gradient here only needs an x input, so I'm interested in plugging the 2 into this. So we're going to have dy by dx, and I'll just use the notation that I think you probably are familiar with. So that will be 3 bracket 2 squared minus 1, and that is at x equals 2. And so, okay, so 2 squared is 4, 3 times 4 is 12, minus 1 is 11. So we know that the gradient is 11, so that will be dy by dx again, and we know that 11 is, so I'll just say that's equal to the gradient. Okay, so I have the gradient, I have a point, and now it's just back to this. So we have y minus b equals mx minus a. And subbing these in, we get y minus 8 equals 11x minus 2. And then we'll get y minus 8 equals 11x minus 22, and so y equals 11x minus 14. And this here is then the equation of our tangent to the curve at this point. In our final example, we're going to find the equation of the tangent to the curve y equals 12 over the square root of x at the point x equals 4. Now again, we see this is a little bit different from the previous example, because in the previous example we were given a point, whereas here we're only told that x equals 4. And in order to find the equation of the line, we have to have the full point as well as the gradient. So what I'm going to do first is actually find out what is the whole point. In order to do that, I need to, of course, find out what is y when x equals 4. And we already have an equation that relates y and x, so I can simply sub 4 into this equation. So to find that out, I'm going to take y equals 12 over the square root of x, and I'm going to sub 4 in. So we'll have y equals 12 over the square root of 4. And the square root of 4 is 2, so 12 divided by 2 is 6. So the point then is P 4, 6. 4, 6. So now I have my point, and now this is just back to the standard, exactly what we've done before, but I'll work through the whole example anyway. So I need to find also the gradient, and in order to find the gradient I have to differentiate this, but I see that the equation that we have is not in differentiable form. So before I even start, I'm going to just write my equation down, 12 over the square root of x, and adjust this using the rules that we looked at in the previous videos. So square root of x is x to the half, bring that up, that's 12x to the minus 1 half, and then I can differentiate it now. So that will be now dy by dx equals, that would be, so minus 1 half times 12 is negative 6x, and minus 1 half minus 1 would be minus 3 over 2. Now, since I actually have to evaluate this, what I'm going to do is put this back into sort of root form, root form, so that I can do it without a calculator. So let me move the x back down to the bottom first. So that will be minus 6 over x, and bottom number's root and top number's cubed. So that will be the square root of x cubed. And let me just give myself some room here. So now I want to evaluate this when x equals 4. So we're going to have minus 6 over 4 cubed, and that will be the square root of that, and that's when x equals 4. Okay, so let's see. So the square root of 4 is 2. 2 cubed is 8. So we'll have minus 6 over 8. And simplifying this fraction, we'll have minus 3 over 4 because 2 is our common factor. And that is the gradient of the line. So I have the point P4, 6. And the gradient minus 3, 4. So now I can just sub these in. So I'm going to have now y minus b equals mx minus a. And I'll have then y minus 6 equals minus 3 over 4 x minus 4. And this is one of those ones where instead of moving this 4 over here, it would make more sense to just multiply it through, because the bottom number will cancel off quite nicely there. So I'll just do it like this. So we'll have y minus 6 equals minus 3 over 4x. And minus 3 over 4 times minus 4, well, 2 negatives make a positive, and those 4's cancel. So you would just end up with plus 3. And then finally moving the 6 over, we will get y equals minus 3 over 4x plus 9. So just to be clear, the equation of the tangent to the curve y equals 12 over the square root of x when x equals 4 is y equals minus 3 over 4x plus 9.